Which of the following statements is true about Bernoulli naive Bayes in scikit-learn? A. Bernoulli naive Bayes is suitable for classifying categorical features where each feature can take only two values, e.g., 0 or 1. B. It assumes that the features are conditionally independent given the class label. C. It uses a binomial distribution to model the probability of each feature. D. All of the above. True. Bernoulli naive Bayes is specifically designed to handle binary features, where each feature can be either present 1 or absent 0. This makes it suitable for classifying categorical data with only two possible values. True. Like all naive Bayes models, Bernoulli naive Bayes makes the assumption of conditional independence. This means that the presence or absence of one feature does not depend on the presence or absence of other features given the class label. This assumption simplifies the calculations, but it might not always hold true in real-world scenarios. True. Bernoulli naive Bayes utilizes a binomial distribution to model the probability of a feature being present 1 or absent 0 given the class label. The binomial distribution helps to calculate the likelihood of observing a specific number of successes present in a fixed number of trials features. True. All the statements A, B, and C are true about Bernoulli naive Bayes, making option D the correct answer. D. All of the above. A probabilistic classification algorithm based on Bayes' theorem and the naive assumption of feature independence. Naive Bayes is a simple but powerful classification algorithm that uses Bayes' theorem to calculate the probability of a data point belonging to a particular class. It assumes that features are independent of each other, which means the presence or absence of one feature does not affect the probability of another feature. This assumption simplifies the calculations but might not always hold true in real-world scenarios. A variant of naive Bayes specifically designed for binary features, where each feature can be either present 1 or absent 0. Bernoulli naive Bayes is a specialized version of naive Bayes that is particularly well suited for classifying data with binary features. It assumes that each feature can be either present 1 or absent 0 and uses a binomial distribution to model the probability of a feature being present or absent given the class label. The assumption that the presence or absence of one feature does not depend on the presence or absence of other features given the class label. Conditional independence is a key assumption in naive Bayes models. It simplifies the calculations by assuming that features are independent of each other given a class label. This assumption can be helpful in many cases, but it is important to be aware of its limitations and the potential impact on the model's performance. A discrete probability distribution that describes the probability of a number of successes in a sequence of independent trials. The binomial distribution is used in Bernoulli naive Bayes to model the probability of observing a specific number of successes presence of a feature in a fixed number of trials features. It helps to calculate the likelihood of observing a feature being present or absent given the class label. Text classification. Categorizing documents or emails into predefined categories based on word presence or absence. Classifying customer reviews as positive, negative, or neutral based on the presence or absence of certain words like amazing, terrible, or okay. Sentiment analysis. Determining the sentiment positive, negative, or neutral expressed in text data. Analyzing social media posts to gauge public opinion about a new product based on the sentiment expressed in the posts. Social media analysis. Analyzing social media posts to understand trends, sentiment, and customer preferences. tracking the popularity of certain hashtags or identifying emerging trends in social media. Discussions. From sklearn, naivebayes import Bernoulli NB. From sklearn, model selection import train test split. From sklearn, metrics import accuracy score. Xtrain, Xtest, Ytrain, Ytest train test split X, Y, test size 0.2, random state 42. BNB Bernoulli NB. BNB, fit Xtrain, Ytrain. YPRED BNB, predict Xtest. Accuracy score test, YPRED. Print accuracy. You are building a spam detection model for emails using sklearn's categorical naive Bayes. You have a dataset with text emails and labels indicating if they are spam or not. How would you prepare your data for this task? A. Convert the text to numerical vectors using TF-IDF, then fit categorical NB to the vectors. B. Tokenize the text into words, then fit categorical NB to the word frequencies. C. Convert the text into numerical vectors using one-hot encoding, then fit categorical NB to the vectors. D. All of the above. True. TF-IDF term frequency inverse document frequency is a widely used technique for representing text as numerical vectors. It captures the importance of words in a document relative to the entire corpus. The resulting vectors can be used directly with categorical NB. TF-IDF. True. Tokenization is the process of breaking down text into individual words or units. You can then count the frequency of each word in each email and use these frequencies as features. For categorical NB. Tokenization. True. One-hot encoding is a technique where each unique word in the vocabulary is represented as a binary vector. This encoding is suitable for categorical NB, as it treats words as categorical features. One-hot encoding. True. All the approaches mentioned in the options are valid for preparing text data for a categorical NB model. Categorical naive Bayes categorical NB. D. All of the above. Naive Bayes. Naive Bayes is a probabilistic classification algorithm based on Bayes' theorem. It assumes that features are independent of each other given the class label. Hence the naive assumption. Naive Bayes is particularly effective for text classification tasks. Spam filtering. A naive Bayes model can be trained on a data set of emails labeled as spam or not spam. The model can then predict whether new emails are likely to be spam or not. Bayes' theorem. Bayes' theorem provides a way to calculate the probability of an event occurring given that another event has already occurred. It is the foundation of naive Bayes classifiers. Medical diagnosis. Given a set of symptoms, a Bayesian network based on Bayes' theorem can estimate the probability of various diseases a patient might have. Prior probability. The prior probability refers to the probability of an event occurring before any new information is considered. It represents the initial belief about the event. Weather forecasting. The prior probability of rain on a particular day might be based on historical weather data for that region. Likelihood. The likelihood is the probability of observing some evidence given a particular hypothesis. In the context of naive Bayes, it's the probability of seeing a specific feature value given a class. Fraud detection. The likelihood of a transaction being fraudulent can be calculated based on patterns observed in past fraudulent transactions. Posterior probability. The posterior probability is the probability of a hypothesis being true given that some evidence has been observed. It's the updated belief about the hypothesis after considering the evidence. Customer segmentation. The posterior probability of a customer belonging to a specific segment can be calculated based on their purchasing behavior and other characteristics. Conditional probability. Conditional probability refers to the probability of an event occurring given that another event has already occurred. It's the probability of a happening given that B has already happened. Market research. The conditional probability of a customer buying a product given they have already purchased another product can be analyzed to understand cross-selling opportunities. Feature engineering. Feature engineering is the process of creating new features from existing data. This involves transforming raw data into features that are more informative and relevant to the machine learning model. Predictive maintenance. New features can be engineered from sensor data to improve the accuracy of models that predict machine failure. Text preprocessing. Text preprocessing is the process of cleaning and transforming text data before it's fed into a machine learning model. This typically involves tasks like removing punctuation, stop words, and converting text to lowercase. Sentiment analysis. Text preprocessing helps in removing noise from text reviews, making it easier for a model to extract sentiment information. Stop words removal. Stop words are common words like a, and is that don't carry significant meaning in text. Removing them can improve model performance by focusing on more informative words. Document retrieval. Stop words removal helps in retrieving more relevant documents by focusing on the key terms in search queries. Stemming. Stemming is a technique for reducing words to their root form. It helps in grouping related words together. For example, running, runs, and ran would be reduced to run. Topic modeling. Stemming can be used in topic modeling to identify clusters of related words and discover underlying topics in a text corpus. Lemmatization. Lemmatization is similar to stemming, but it aims to find the canonical form of a word, taking into account its grammatical context. For example, better would be lemmatized to good. Natural language processing. NLP. Lemmatization helps in improving the accuracy of NLP tasks by using the correct base form of words. Data standardization. Data standardization involves transforming data to have a common scale or distribution. This is particularly important for algorithms that are sensitive to the scale of features. Regression analysis. Standardizing features in regression analysis can help prevent features with larger scales from dominating the model. Data normalization. Data normalization is a technique used to scale data to a specific range, typically between 0 and 1. This helps in preventing features with larger ranges from dominating the model. Neural networks. Normalizing data is often essential for neural networks, as it can improve the convergence of the training process. Data scaling. Data scaling involves transforming data to have a specific range. This can involve standardizing data to have zero mean and unit variance or scaling data to a specific range, such as 0 to 1. Clustering. Scaling data is important for clustering algorithms, as it can prevent features with larger scales from influencing the clustering results. Suppose you have a dataset of emails with labels indicating whether they are spam or not. You want to build a naive Bayes model to predict spam emails based on the word frequencies in the emails. This is a great deal. Buy now. 1. Urgent. You have won a lottery. 1. Hello, how are you doing? 0. Check out this amazing product. 1. Let's meet for coffee tomorrow. 0. You can calculate the probability of an email being spam based on the frequency of certain words. For example, the word deal might appear more often in spam emails than in legitimate emails. The naive Bayes model calculates the probability of an email being spam based on the occurrence of Specific words. P spam words, P words, spam, P spam, P words. You are tasked with building a model to predict customer churn for a telecommunications company. The data includes categorical features like customer plan type, device type, and customer satisfaction. Which sklearn naive Bayes algorithm would be most appropriate for this task? A. Gaussian NB. B. Bernoulli NB. C. Categorical NB. D. Multinomial NB. A. Gaussian NB. Gaussian NB assumes a Gaussian distribution for the features, which is not suitable for categorical features. This would lead to incorrect probability estimates. False. B. Bernoulli NB. Bernoulli NB is designed for binary features 0 or 1. While it can handle categorical features, it might not be optimal as it treats each category as a separate binary feature. This could lead to information loss and inaccurate results. False. C. Categorical NB. Categorical NB is specifically designed for handling categorical features, making it the ideal choice for this churn prediction problem. Its underlying probability model assumes a categorical distribution, allowing it to effectively capture the relationships between categorical variables and the target. Variable churn. True. D. Multinomial NB. Multinomial NB is suitable for features representing counts or frequencies. While it can handle categorical features, it's more appropriate when dealing with features representing the frequency of events, such as the number of times a word appears in a document. False. C. Categorical NB. Naive Bayes. Naive Bayes, a probabilistic classification algorithm based on Bayes' theorem, assuming independence between features. For instance, if we want to predict whether an email is spam or not, naive Bayes could be used. It would analyze words in the email features and their frequencies to determine the likelihood of the email being spam. It assumes that the occurrence of each word is independent of others, though in reality, there might be some dependence. Categorical distribution. Categorical distribution. A probability distribution that describes the likelihood of different categories within a dataset. For instance, imagine a survey where people are asked about their favorite color. The categorical distribution would represent the probability of each color being chosen, e.g., 30 red, 20 blue, 50 green. Categorical NB uses this distribution to estimate the likelihood of observing certain categories in a feature given a particular class. sklearn, naivebayes, categorical NB. sklearn, naivebayes, categorical NB. Naive Bayes classifier for categorical features based on the categorical distribution. It utilizes the categorical distribution for the likelihood of the features given the class and a prior probability of the classes. A smoothing parameter alpha can be used to prevent zero probability issues. Consider a dataset of customer churn, where the features are categorical like plan type basic, premium, device type smartphone, tablet, and satisfaction satisfied, neutral, dissatisfied. We want to predict churn yes or no. Categorical NB would use the categorical distribution to calculate the probability of each feature combination given the class churn or not. It then uses Bayes' theorem to calculate the posterior probability of churn based on these probabilities. The smoothing parameter alpha can help to avoid issues where a particular combination of features has not been observed in the training data. Customer churn prediction. Customer churn prediction. Identifying customers who are likely to discontinue their service or subscription. It is a critical aspect of customer relationship management. In the telecommunications industry, churn is a significant concern. Companies strive to minimize churn by proactively identifying and addressing factors that lead to customer dissatisfaction. By predicting churn, companies can implement targeted retention strategies, such as offering discounts, personalized offers, or improved customer support, to retain valuable customers. From sklearn, naivebayes import categorical NB. From sklearn, model selection import train test split. From sklearn, metrics import accuracy score. Xtrain, Xtest, Ytrain, Ytest train test split X. Y. Test size 0.2. Random state 42. Model categorical NB. Model, fit Xtrain, Ytrain, Ypred model, predict Xtest. Accuracy score test, Ypred. Print accuracy. You are building a spam filter using naivebayes. Which variant of naivebayes is best suited for dealing with imbalanced datasets? Where spam emails are significantly less frequent than legitimate emails? A. Gaussian NB. B. Bernoulli NB. C. Multinomial NB. D. Complement NB. Gaussian NB assumes features follow a Gaussian distribution and is not specifically designed for imbalanced datasets. LT font style font size 12px GT choices LTBRGT LT font style font size 10px GTA. Gaussian NB LTBRGTB. Bernoulli NB LTBRGTC. Multinomial NB LTBRGTD. Complement NBLT font GT. Bernoulli NB is suitable for binary features 0 or 1 and doesn't address the issue of imbalanced datasets. LT font style font size 12px GT choices LTBRGT LT font style font size 10px GTA. Gaussian NB LTBRGTB. Bernoulli NB LTBRGTC. Multinomial NB LTBRGTD. Complement NBLT font GT. Multinomial NB works with discrete features and is not specifically optimized for imbalanced data. LT font style font size 12px GT choices LTBRGT LT font style font size 10px GTA. Gaussian NB LTBRGTB. Bernoulli NB LTBRGTC. Multinomial NB LTBRGTD. Complement NBLT font GT. Complement NB is specifically designed to handle imbalanced datasets. It adjusts the class probability estimates by considering the complement of the class, making it more robust in scenarios where one class is significantly more frequent than the other. LT font style font size 12px GT correct answer LTBRGT LT font style font size 10px GTD. Complement NBLT font GT. D. Complement NB. A probabilistic classification algorithm based on Bayes' theorem. It assumes independence between features, making it computationally efficient. It is commonly used in spam filtering, sentiment analysis, and medical diagnosis. Spam filtering classifying emails as spam or legitimate based on word frequencies and other features. Sentiment analysis determining the sentiment of a piece of text as positive, negative, or neutral. Let's say we have a dataset of emails with features like word frequency in presence of specific words. We want to predict whether an email is spam class spam or not class not spam. Using naivebayes, we can calculate the probability of an email belonging to each class given its features. For example, if an email has a high frequency of words like free and money, it's more likely to be spam. A variant of naivebayes designed to handle imbalanced datasets. It adjusts class probabilities to account for the imbalance. improving accuracy in such situations. It utilizes the complement of the class to adjust probability estimates, making it more reliable for skewed data. Fraud detection, identifying fraudulent transactions in a dataset where legitimate transactions are significantly more common. Medical diagnosis, detecting rare diseases in a dataset where most patients are healthy. Spam filtering, identifying spam emails in a dataset where most emails are legitimate. In a spam filtering scenario, if we have 1000 emails, 900 are legitimate and 100 are spam. A regular naive Bayes might misclassify spam emails due to the imbalance. Complement NB adjusts the probabilities to account for this imbalance, making it more reliable for classifying spam emails. Datasets where the number of samples in one class is significantly higher than in other classes. This can lead to biased models that favor the majority class. Fraud detection, where fraudulent transactions are significantly less frequent than legitimate transactions. Medical diagnosis, where rare diseases occur in a small proportion of patients. Consider a dataset of loan applications, where 95 of applications are approved and 5 are rejected. A model trained on this dataset might have a high accuracy but could struggle to accurately predict rejections due to the imbalance. Techniques used to adjust class probabilities in imbalanced datasets to improve model performance. These techniques aim to mitigate the bias towards the majority class. Spam filtering, adjusting the probability of an email being spam to account for the fact that most emails are legitimate. Fraud detection, adjusting the probability of a transaction being fraudulent to account for the fact that most transactions are legitimate. In the loan application example, we can adjust the probability of an application being rejected by considering the ratio of rejected to approved applications, effectively reducing the bias towards approved applications. LT font style font size 20 px GT LTBGT question LTBGT, which of the following statements is true about Gaussian naive Bayes in scikit-learn? LT font GT. LT font style font size 16 px GTA. AMP and BSP, it handles categorical features directly without any encoding. LT font GT. Incorrect. Gaussian naive Bayes, by default, does not handle categorical features directly. It assumes a Gaussian distribution for continuous features and requires categorical features to be encoded, e.g., using one-hot encoding. False. LT font style font size 16 px GTB. AMP and BSP, it assumes a Gaussian distribution for continuous features. LT font GT. Correct. The Gaussian in Gaussian naive Bayes indicates that it assumes a Gaussian normal distribution for continuous features. This means it models the probability of each feature value within a class using a bell-shaped curve. True. LT font style font size 16 px GTC. AMP and BSP, it handles both continuous and categorical features. LT font GT. Correct. While it assumes Gaussian distribution for continuous features, Gaussian naive Bayes can also handle categorical features if they are properly encoded. It uses a multinomial distribution for categorical features. True. LT font style font size 16 px GTD. AMP and BSP, all of the above. LT font GT. Correct. Since options B and C are true, option D is also true. True. LT font style font size 16 px GTD. AMP and BSP, all of the above. LT font GT. All the statements A, B, and C are true in the context of Gaussian naive Bayes in scikit-learn. Therefore, Option D. All of the above is the correct answer. LT font style font size 20px GT LTBGT related concepts LTBGT LT font GT. LT font style font size 16px GT LTBGT naivebayes LTBGT LT font EGT. LT font style font size 14px GT a probabilistic classification algorithm that applies Bayes' theorem to calculate the probability of a class given a set of features. LT font GT. Imagine you are trying to classify emails as spam or not spam. Naive Bayes can use features like the presence of certain words free money, click here, the email's sender, and the length of the email to calculate the probability that an email is spam based on observed features. LT font style font size 16px GT LTBGT Bayes theorem LTBGT LT font EGT. LT font style font size 14px GT a mathematical formula that describes the probability of an event occurring based on prior knowledge of conditions related to that event. LT font GT. Let's say you have a medical test for a disease. Bayes' theorem can help you calculate the probability that someone actually has the disease given a positive test result, taking into account the prior probability of the disease in the population and the accuracy of a test. LT font style font size 16px GT LTBGT Gaussian distribution LTBGT LT font GT. LT font style font size 14px GT a continuous probability distribution that describes a bell-shaped curve often used to model real-world data. LT font GT. You can use a Gaussian distribution to model the heights of students in a class. The majority of students will have heights close to the average height, and the number of students with heights further away from the average will decrease gradually. This is represented by the bell-shaped curve. LT font style font size 16px GT LTBGT multinomial distribution LTBGT LT font GT. LT font style font size 14px GT a discrete probability distribution used to model a probability of occurrences of events, where each event has more than two possible outcomes. LT font GT. Consider a dice roll. Each roll can have 6 possible outcomes 1, 2, 3, 4, 5, or 6. The multinomial distribution describes the probabilities of getting each of these outcomes after multiple rolls. LT font style font size 16px GT LTBGT sklearn sklearn LTBGT LT font EGT. LT font style font size 14px GT a popular Python library for machine learning, providing tools for various tasks including classification, regression, clustering, and more. LT font GT. You can use scikit-learn's Gaussian NB class to build a Gaussian naive Bayes classifier. This class offers methods to train the model on your data, predict new data, and evaluate the performance of the model. LT font style font size 16px GT LTBGT Gaussian NB LTBGT LT font EGT. LT font style font size 14px GT a class in scikit-learn that implements the Gaussian naive Bayes algorithm for classification. LT font GT. In your Python code, you can create a Gaussian naive Bayes model like this from sklearn. Naivebayes import Gaussian NB. Model Gaussian NB. Model. Fit xtrain. Y train. This creates a model, fits it to your training data, and then you can use it to make predictions on new data. LT font style font size 20px GT LTB GTUSE cases LTB GT LT font GT. LT font style font size 16px GT spam detection categorizing emails as spam or not. LT font GT. Using features like the presence of specific words, sender's domain, and email length, naivebayes can calculate the probability of an email being spam. It can then classify emails as spam or not based on these probabilities. LT font style font size 16px GT sentiment analysis classifying text as positive, negative, or neutral. LT font GT. By analyzing the words used in text and their sentiment, naivebayes can determine the overall sentiment of a piece of text. This can be useful for understanding customer feedback, social media posts, or news articles. LT font style font size 16px GT medical diagnosis predicting the presence or absence of a disease based on symptoms and medical history. LT font GT. Naivebayes can be used to predict the likelihood of a disease based on a patient's symptoms, medical history, and other relevant factors. It can help doctors make informed diagnoses and recommend appropriate treatment plans. You are tasked with building a spam detection model using the naivebayes algorithm. Which type of naivebayes is best suited for text data? And why? Gaussian NB ideal for continuous data, like numerical features. Bernoulli NB suitable for binary features, like presence or absence of a word. Multinomial NB best for text classification, as it handles word counts. All of the above each has its specific use case. False. Gaussian NB is better suited for continuous data, such as height, weight, or temperature. Text data, however, involves discrete features like word presence or frequency. Gaussian NB ideal for continuous data, like numerical features. False. Bernoulli NB works well for binary features e.g. presence absence of a word. But for spam detection, we often consider word frequency, which is better handled by multinomial NB. Bernoulli NB suitable for binary features, like presence or absence of a word. True. Multinomial NB is the preferred choice for text classification. It excels at handling word frequencies, making it effective for spam filtering, sentiment analysis, and topic modeling. Multinomial NB best for text classification, as it handles word counts. False. While each naivebayes variation has its use cases, multinomial NB is specifically designed for text classification, making it the best option for this task. All of the above each has its specific use case. C. Multinomial NB best for text classification, as it handles word counts. A probabilistic classification algorithm that applies Bayes' theorem to calculate the probability of a data point belonging to a certain class. Naivebayes, a mathematical formula that describes the relationship between prior probabilities, likelihoods, and posterior probabilities. Bayes' theorem, converting raw text into a format that can be understood by machine learning models. Text preprocessing, converting textual features into numerical representations that machine learning algorithms can process. Feature extraction, a scikit-learn tool used to create numerical feature vectors from text data. Considering the importance of words within a document. TF-IDF vectorizer, spam detection identifying and filtering unwanted emails. Sentiment analysis determining the emotional tone of text positive, negative, neutral. Topic modeling discovering underlying themes and topics in a collection of documents. Document classification categorizing documents into predefined classes. Use cases. Get free money now. Click here to claim your fortune. True. Meeting scheduled for tomorrow at 10 a.m. Please RSVP. False. Buy cheap Viagra online. No prescription needed. True. In this example, we would train a multinomial NB model on the text data and associated spam labels. The model learns the frequency of words like free, click, money, buy, and Viagra in spam vs. non-spam emails. When a new email arrives, the model calculates the probability of it being spam based on the frequencies of these words.